Hello and welcome to Two Dancing Clams. This is part 2 of the Stone Arch Bridge tutorial. In the break I did just a little cleaning up, but nothing else. In this part of the tutorial we'll create these stone arches at the base of the bridge, we'll create rails on the top of the bridge, and we'll UV unwrap and texture everything. I'm going to start with these stone arches. So we want to take these curves and extrude them. We'll get the curves after they've been realized, but before they've been turned into points. First off, I'm going to do something a little strange. This is a good time to mark the ends of each curve. This will become important when we UV unwrap, and also later when we want to make the ends of the arches flat with the ground. So we'll essentially mark each point that belongs to the end of the curve. Now I want to do the same trick we did with the sides of the bridge. So take the curve, push it to the back side of where we want the stone arch to be, and then extrude it forward again. So to do that, we want to know how much to do that. So to do that, we need to know what the width of the arches is going to be, which is generally going to be just a little bit wider than the bridge is, so they protrude. We'll create a new variable for that and make it just a little bit wider than the bridge. We're going to use set position to push the curve backwards. We're going to do a vector math multiply to change the value into a vector, divide it by 2, and make it negative all at a go. Easily done. And that will be our offset. Let's take a look at what we're doing. Impressive. Now, we want to extrude this back forward again. So take the curve, turn it to a mesh, and extrude it. We'll be extruding edges because that's what we're dealing with. We want to extrude it by the arch's width amount. There we go. Now we'll do another extrude mesh to give these some solidity. This time we'll be doing faces. And we'll create a new variable to control that thickness. Call it arch thickness. I'm so inventive. And we will use that. So drag this out into space and type in group input and use our new variable. Nice. So this shows two things. One, this will give us faces at the front, and this will restore the faces at the back. So now we have a solid. And you can also see here where the ends are a little bit canted. That drove me crazy. So that's the reason we mark the edge of the curves. So at some point we're going to go back and make those last faces flush with the ground to get rid of that effect. At this point, if you're anything like me, you'll be tempted to throw in a merge to combine everything into one. Don't do it. The reason is because we're going to create another copy of this, except instead of have it be arched, it's going to be flat block rectangles, and that's what we're going to form the UV map with. But merge by distance does not produce a predictable order of vertices in the result. We want our UV unwrapping object to match our curves, vertex for vertex. And if you do a merge by distance, you won't be able to predictably do that. I don't know why, it's just there's some randomness in there. Let's go ahead and flatten the ends of the arch now. We will use the attribute we created earlier that we called ends. Take the current position, multiply it by everything except y. This will leave the x and z values alone and set y to 0, and y equals 0 is the origin. And we will do that on these marked vertices. And voila! The power of store-named attributes is amazing. So we mark the ends of the curves, but as the ends of the curves turned into an extruded plane, turned into a 3D object. Every vertex that was created from one of the original ends also gets marked with this Boolean. So by the time we get here, the corners of these bottom faces are all marked with that same attribute. And we can just zero out the y, and we are done. First, clean this up a little bit. Now we'll UV unwrap this. The strategy is to create rectangular objects that parallel these. And what we're going to do is create the UV map on the rectangular objects and then copy it over to the curved objects. This will lead to the texture linearly following the arch, and it'll look good. We'll start with the same curved mesh we created right up here. To flatten out the arch, what we're going to do is come up with an x value based on its index, set the y to one of two different values, and leave the z alone. So what this does is it takes the index, multiplies it by minus 0.2. This value here, the 0.2 doesn't matter, the minus sign does. Because if the points on the arch go right to left, as they do, we want these points to go right to left so they match. We'll use that for the x-coordinate and do a set position. And now we have the basis for our rectangular object. We'll extrude it to turn it from one-dimensional object into a two-dimensional object. Now will be edges, of course. And we'll just carry the vector 1 unit z. Now we'll do a similar thing we did above. We have to do the identical thing we above. So this will form one set of faces. We will extrude to get the edges and the other set of faces. So we'll extrude it in the minus y direction. Again, this value isn't nearly so important as the fact that it's negative, because we care about what direction it goes in. And it's nice to offset by the same thickness that we're using for the arches themselves. It makes the textures line up better. It's not required, just makes it a little bit nicer. And we don't want this to be individual. Now, one good thing to do to double check right now is, and this is strictly optional, let's bring up the spreadsheet and check that our geometries really are parallel, at least in terms of face counts, vertex counts, and edge counts. So if we pull up the viewer on this, we can see 192, 312, 124. And if we look at the other one, Control-Shift-Click to move the view over to the other one, 192, 312, 124. So if those don't match, this UV mapping trick can't work. But even if they do match, there can still be discrepancies, as I said previously, with the dreaded merge by distance. But this is a pretty good sign we're on the right track. I'm just going to revert real quick to get back to my save point. Now let's UV unwrap this. UV unwrapping is trivial. It's just a couple of boxes. The trick in UV unwrapping is coming up with a Boolean equation to describe the seams where the map can be separated for the UV unwrapping. In this particular case, I'm going to use all the edges that run along the x direction, which means if I take one endpoint, subtract it from the other, the x value is not equal to 0. And we're also going to unwrap everything at the end of a block. So this face, this face, this face, and this face. And that'll get us a nice complete unwrapping. And that's also when we get to use our Boolean named attribute that we'd saved earlier called ends. We'll do it. Start with the edge vertices. So again, we'll subtract the ends. We will grab the x-coordinate, and we will look for any result that's not equal to 0. And that is one of the conditions. The other condition is the named attribute that we called ends. And this Boolean equation will form the seam, so the UV unwrapping knows where to split the object. The one slightly tricky thing is, this is the geometry we're using for the unwrap. However, we want to apply the unwrap to the curved arches. So to do that, we need to transfer the map from one geometry to another, and one of the ways we can transfer geometry is with a sample index. Again, if you're using Blender 3.3, this will be a transfer attributes. And to use the UV map, we need it also stored as a named attribute. I always call mine UV Unwrap, just for sake of sanity. It's a vector. It must be stored in the face corner domain. And there we go. And we see nothing. And this has to be face domain too. I mean face corner. Now I want to show what we've done. So let's go to Material Preview. Going to go to my asset file. And first, let's set material. I'm not just going to put the material in here. I'm going to create, I like to have the materials exposed on the user interface so they're easy to change on the fly. And that will give us a variable. I'm going to change that to material arches. I'm going to use the floor clinkers material from Polyhaven over here. And we see something, but we're not using the UV map yet. Go to the shader editor, A dot, so we can see what we're doing. And we'll bring in the attribute that we stored in the geometry nodes, pull it up here, use it for the UV map, and that looks good. Love this trick. And again, if we didn't do our UV unwrapping on the rectangular part, what we would get is, let's just say, not nearly as good. Also, I have a video that gives us a set of node groups to make dealing with stuff like this easier. It also allows you to independently control each face of the unwrapped material for location, scale, rotation. It's really handy. Again, don't want to use it here because I don't want to go to the construction of it, and I also don't want to make this video dependent on you downloading that project file before you can do this one. Now is a good time to texture the main part of the bridge and UV unwrap it. So first, let's get rid of the arches temporarily so they won't be in the way. Now on this bridge faces thing, right after we filled the curve, we created the front and back faces and joined them together. So these will be one texture. And when it gets to more complicated designs like this, I find it really helpful to label these set material boxes so I can keep them straight. And we're going to create materials in the user interface for these. And we're going to need materials for all 4 parts of the bridge, so let's go ahead and create the other 3 now. In addition to the materials for the bridge faces, we'll need one for the top surface, which I call the deck, and another one for the rails. Hook this up to bridge faces material, and let's go ahead and select a material for that. Again, I'm going to use something from Polyhaven just because they're the easiest. So I'm going to use medieval blocks for the sides of the bridge and mud for the deck, and I'm going to use reuse clinkers for the rail. And these textures will be linked in the description. Let's get rid of this window. We don't need it anymore. We won't see much until we UV unwrap this, but let's go ahead and apply texture to the top and the ends of the bridge as well. Now, if you don't mind the ends and the top having the same texture, this is a lot easier. But I don't think it looks good unless the ends of the bridge match the side texture, because that same material is going to form the whole basis of the bridge, and if it's different from side to side, it'll look strange. If you can see it, then again, you could bury it in the side of a hill. It's up to you, but I'm going to give them different textures. So I want a way to set the material for a certain selection. And in this case, I want to select out the ends of the bridge. It's pretty easy, because if we consider only the faces, not the edges, not the vertices, just the faces, The faces at the ends of the bridge are the only ones that point out directly along the x-axis. So if we do a capture attribute in the face domain, we can look at this normal and see what direction it's pointing. We want just the x. And because it could be -1 or +1, we'll take the absolute value. And we want to see if it's equal to 1. And we'll use that to conditionally set the material. So we're going to use the same material as the face, as discussed previously. And now we want to set a different material on the top of the bridge, or the deck. And this is easy because these front and back faces are not in our geometry. So the only thing we have is the top, the bottom, and the ends. So if it's not the ends, it's the top or the bottom. So we could do a not. And use that as our selection criteria. Now I think it's a good idea just to check where we are in these materials to make sure we're heading in the right direction. So I'm going to bring up the shader editor. And we won't see much. So this is a medieval block. So this should be on the ends of the bridge and the faces. So this is not what we want, but it will at least show us where this texture is. And yep, it's on the ends and it's on the faces. And then if we go to the mud, which should be on the top, again, if we switched over to generated, it won't be perfect, but at least we'll see something. And we can see that's on the top. So we are definitely making progress. Let's go back to geometry mode editor. Now we just need to UV unwrap this. And it's pretty easy in this case. If we look at the wireframe, pretty much everything is a seam except for these divisions along the deck that go back to front, and the divisions along the arches that also go back to front. So let's suppose we take this line here and we subtract the endpoints. We'll get a z value that is bigger than 0 or less than 0. Just it won't be 0. And the same is true for all the lines like this. So if we just select the lines whose endpoints, when subtracted, have a z value of 0, that basically gives us everything except these back to front lines we don't want. The one thing it won't include are the lines at the end of the bridge, which we do want to include in the seam. So to get those, we'll just check the x value of the position to see if it's equal to the end of the bridge. And those are our two conditions. So let's see what we've done. So again, once subtracting the endpoints, if the z value is 0, that gets rid of all of these lines we don't want. Or if the x position multiplied by 2. So again, the bridge is going to straddle the origin, so it's going to go half the bridge length this way and half the bridge length this way. So if we multiply that by 2, we get the bridge length. And if we compare these x values to the bridge length, if it's equal, we know we're dealing with one of these 4 edges at the end. And that gives us our UV unwrap. And one thing I like to do when I'm ever working on things like this is just check it. So what I'm going to do is I'm going to delete all the edges that are not selected by this. And that should show us what we're using as seams. And there you go. So the seams are the vectors along the edge of the bridge and the vectors at the end. That is perfect. Now we will UV unwrap the way we always have done. This will be our seam. The UV map is created with a store named attribute. I always call this UV unwrap. It is a vector. It is always in the face corner. You can call this anything you want, but I find if I use a consistent name, then I make fewer mistakes. Now let's see this UV map in action. We will store the UV map into the attribute, go back to the shader editor, a dot to recenter the view, and now we won't use this generated anymore. Instead, we'll get an attribute that we called UV Unwrap, and we get a nicely textured top of the bridge. And if we go to medieval blocks that we're using for the faces, do the same thing. And we get the sides and the end of the bridge. And I think this one looks better rotated. Yeah. Perfect. It is a little bit confusing that there's one UV map for the entire bridge, but of course we have several textures on it, so we need to set them independently. Let's go back to the geometry node editor and bring in the arches again. Getting close, getting close. One less detail. I don't think the bridge looks right unless there's some rails along the edge. So let's take care of that now. The cosine curve that we created for the top profile of the bridge will also do quite nicely for the rails. So let's grab that. So here's our cosine curve box, and we'll grab it before we turn it into points. This is a perfect job for a curve to mesh. We'll just give it a rectangular profile and generate a rail. That might be a touch too big. Let's put these in the user interface. That's more like it. I should not have gotten rid of the bridge because we need it as a guide. And we do want the end caps. We're going to unwrap the rail exactly the same way we unwrapped the arches. And it's easiest to do this while we still have a single copy of the rail. That way we can UV unwrap it like it is and then texture it and duplicate it and get the benefit for both the near rail and the far rail. So we want to create a rectangular analog for our curved object. It's going to start with a curved line. Generally, I find it works best if the rectangular object has similar dimensions to the curved object we're UV unwrapping for. So let's make the length of it the same length as the bridge. So we'll use the bridge length, but just the x-axis. The curved rail has a hump resolution number of segments, so let's give this the same. Something about hump resolution just makes me happy. And when we're unwrapping this, it's going to be useful to know the ends of the curve. So let's mark those with a store named attribute, again like we've done before on this. So each end of the curve will be marked with a Boolean. And when we turn this into a 3D object, the faces at the end of the rails will be marked as ends. And for turning the curve into the mesh, we might as well just reuse this. D. Now we're going to generate the UV map on the rectangular object, but copy it over to the curve geometry. To do that, we need a sample index. On Blender 3.3, this will be a transfer attributes. We're transferring a vector, always the face corner domain. Now this value here is going to be the UV map, which we'll generate in just a second. But let's finish this out. The UV map always goes into the face corner domain. I always use the name UV Unwrap so I can remember what it is. And we store the map into there. And then we'll later pull it out in the material. But now we need to do the Boolean equation that describes the seam for the UV unwrap. So to generate this seam, we're going to use tricks we've already used. Grab the edge vertices and subtract them. This time we're interested only in the x. What we've done, subtract the endpoints, grab the x. If the x of the result is equal to 0, that means we have one of these edges that's running front to back. If it's not that, then we have one of the edges that are running side to side, and those are the ones we want to use to unwrap. Those and the ends of the bridge, which we have marked with a Boolean. That should be our UV map. Now if we set a material, and we already had clinkers set for that over here, so we get it. And you can see the texture is following the outline of the rail. Now we just need to move this rail to where it belongs and duplicate it. We're going to move it to the edges with a set position. Actually, two of these. Control-Shift-D to duplicate. We'll want one for each rail. This is just a way to duplicate the object easily. Now we're going to use bridge width as the basis for this. And we're going to add in just another little factor so that the user can nudge the rails wider or narrower. And call that rail offset. Now we want to move one forward and one backward by the same amount. We have a group to help with that. Our value to vectors node. This time we're working in the Z. Pull those back in. And if I remember correctly, yeah, the rails are half embedded in the bridge because the curved mesh is centered, so we want to move them up a little bit. This is easily taken care of where we created the rail. Just give it a little goose in the Y. I know we're looking at it on its side, but really it is the Y. And just one final touch. Let's get this thing right side up. Rotate it 90 degrees around the x-axis. X-axis, 90 degrees. Lovely. Let's get some decent light on this. And I think one arch is prettier than two on a small bridge. One last thing about textures. If we render this in cycles, you can see everything goes nuts. And I'm not exactly sure the reason for this. I know it has to do with displacement, so I'll show you the fix first. Go to the shader editor and just kill the displacement on the face and the medbed. So you might conclude that it's the bad geometry in this bridge face that's causing this. But the geometry in the riverbed is perfectly fine, and it happens there too. No idea why. Again, kill the displacement, and everything works great. Again, this is texture specific. It doesn't happen on my procedurally generated textures, and it doesn't happen on most of the textures I tried that came from Polygon. It's only on the ones that came from Polyhaven that seemed to show this, and not just one or two. Most of the ones I tried don't know. But again, turning off the displacement doesn't really change the texture all that much, so no harm, no foul. That's better. And that's the end. I do love this project. It's one of my favorites. I gotta say it's probably my favorite of the large construction projects because the results are so satisfying, especially with the procedurally generated textures. I think it works good also with the nodes I put together to make texture handling easier. It's nice to be able to change like this arch text, even though the arches and the rail are sharing the same texture, it's nice to be able to change them independently. It's also nice to be able to change the top of the arch or the top of the rail separately from the side of the rail. The texture node groups give you just super easy ways to do that. That video will be linked on the left of your screen right now. All of the project file for this is available on Gumroad. All of the Polyhaven textures I use for this are in the description as well. I had a blast making this video. I hope you enjoyed it too.